Okay, so we were able to insert a couple of students. Let's insert a few more. Let's insert Ada. Let's see. Instead of using my bad schema, I will use a proper. I'll be consistent. So this will be Ada. Password. I'll keep the same password. The first name will be Ada, and this will be Lovelace. And we can do a find, and we see that we have 3. Okay. So the finder method, as we saw, returns all the elements, all the records, all the documents in the collection. Or you can pass as an argument. You can pass as an argument the criteria by which you want to retrieve something, very much like the where clause, where you can have name-value pairs of saying, I don't want all the records. I only want the records that have this field equal to this value and that field equal to that other value, right? And do a pattern matching and retrieve for me the records that meet that criteria. So let's copy this. So we can say db.user.find. So this can take as argument an object, and this object you can put the name of the fields that you want to pattern match. It says I want the one whose ID, for instance, the one that has the ID is equal to, right? Let's retrieve Alice. So let's copy this. Now for this, it needs to take as argument an instance of the object ID. The object ID is a native proprietary data type that represents unique identifiers in MongoDB. Right? It's not a string, right? It's an object ID that can be created from a string. Okay? So let's close that JSON object. Let's close the find. And indeed, it finds our Alice. Right, so this took as argument, as you notice, the ID for Alice, the unique identifier, and it came back with Alice. Make sense? You can also retrieve records. I'm sorry. You can retrieve documents by non-key fields, such as, for instance, I want the one whose username is equal to Ada, and it comes back with Ada. Make sense? Now, if you provide other fields, for instance, the one who has also first name Ada, obviously this will come back also as Ada. Notice that the object is providing the argument, the parameter is providing all the fields, is going to pattern match and return those records that match that criteria, that match those values. So if you provide some bogus value, will come back as 0. There's no records that match that criteria, right? So it's treating this comma here as if it were an and, right? Where this is true, right? And also this is true. Although it has a specific and operators, right? That you can use to create much more complex queries. Yeah, so this is a non-key field. Now, notice that they're always coming back with all the fields, right? They're always coming back with the username, the password, the first name, the last name. Oftentimes, you want to use projection, right? Like you would in select, right? In select, you say which fields do you want. Maybe you don't want all the fields, right? So if you want all of them, you would say star. Here, if you don't say anything, you'll always get all the fields of the record, the document. If you provide a second argument, the second argument is used for projection, saying which fields do you want. So for instance, I only want the last name, and 1 meaning something true. I only want the last name, I don't want the other ones. And notice that it came back only with the last name, but it also came back with the underscore ID. So the underscore ID is returned by default, even if you don't specifically ask for it. It assumes that you're also going to need the ID of the record at some point, right, if you want to keep operating on the record. So if you don't want the ID specifically, you need to specifically say that I don't want it, and say -1 or 0. I forget. Is it 0? There we go. So right now you just have the last name. Right? You say I don't want the ID, but you have to specifically not ask for it, or ask for it not to come back. I don't know. All right, so let's take a look at something a little more complex. Let's create another record, another collection, and this time, what's interesting here is looking at creating relationships. Right? Notice that we have a couple of relationships here. There's a one-to-many relationship between a course and a section, right? And so there's several ways that we could implement that in MongoDB. We could use the classical relational approach, which Mongo discourages, all right? But we could still do it. We could have, for instance, a something that behaves like a foreign key, right? That you might have multiple instances of courses, and then you can have maybe a section referencing, or one of the fields in section referencing the ID of the course that it belongs to. That's a classical way of implementing it. Right, so let's do it that way first. Right, then let's consider an alternative implementation, the implementation that MongoDB suggests, where the section would actually be embedded inside the course. The thing is that introduces some questions, right? So being able to perhaps reuse a particular section for something else. If it's embedded inside of the course, how could I use it elsewhere? Right? How would I refer to it inside of there? So it opens up some questions on how to address other relationships, right? If this is embedded inside of the section, right? How would I then relate it to a student, right? If multiple students are in a particular section, right? If that section instance is embedded in the course, that would make it much more complex. So let's consider both and see what we end up with. So first, let's start with creating a couple of sections. Paste without card control. The second thing, control paste. That's fine. Okay, I inserted one section. Let's insert another one. Paste. Oops. Wait, how many did I insert? db.section.find. Okay, I inserted just one. Okay. Let me insert another one here. Then let me insert yet another. And another one. Oops. Copy. Okay, so let's see what we inserted, and we'll do it pretty. So we have 4 sections, right? So we have section 1, 2, 3, and 4. The first 2 presumably belong to course CS 101, and the other 2 belong to course CS 102. Right? Very much like a relational database, right? Presumably these are referencing some courses that don't even exist, which is totally fine because this would not even validate referential integrity. Right? That also would be the responsibility of application level validation. Right? But what this would allow me to do is play around with a couple of things. For instance, I can then ask, retrieve for me not all the sections, only the sections that have the course, whose course are for course CS 101. And notice that it comes back with these 2 courses. Right, these are the 2 sections for that particular course. Or if I ask for course 102, it would bring me the other two sections. Right, here they are. Right, the other two sections of course CS 102. Right, so this allows me to have a little more interesting types of queries. For instance, we might find not only that the course, but we might ask it by find it by seat. Give me the ones who has a particular seat of 45 seats, right? And right now this is the only section that has 45 seats, right? Or we might ask, give me some sections that have the seats within a particular range. Yes. So to do that, we have operators that can compare attributes. For instance, we have less than or greater than, and there's a plethora of operators that are available. Okay, not equal, greater than or equal. But let's play around with just these simple queries. For instance, find me all the sections that have seats are greater than 30. Notice that it has a $sign in front of it. That means that this is a Mongo operator. Right? It's not an actual field. And the query is that first is the field, right? And then the operation that you want on it, right? So it's greater than 30. So it comes back with me with these two sections, right? That have seats of 34 and 45 and they're both for course CS 102, right? So I guess course 101 doesn't have that many seats left. Okay. You can also use operators such as and or not, or there's tons of Boolean operators that you can combine complex to create complex queries. So here's one that retrieves for me the only section that has more than 30 seats but less than 40. So let's do that. Let's take a look at that. And it retrieves for me that this is the only section 3, that has 34 seats. Okay. So notice that the AND operation takes an array of objects, and the array of objects themselves are Boolean operations, okay, that operate on comparing a particular field in each one of the objects against a particular value. Okay. You can also do sorting. So this one says, you retrieve for me all the sections, but I want to sort it by seats. Okay. And this does not modify the original order of the records. Right? It's only for display purposes, right? For our convenience to look at the data in a particular convenient way. So you should never assume that the data is sorted in any particular way, right? For that, we have indices. You can ask MongoDB to create an index for you so that you can improve queries on a particular field. If you have a particular set of fields that you do a lot of query on, it makes sense to index on those fields. Now, sorting takes there is no ascending or descending. The way you do ascending or descending is to use the seats. You can put a negative in front of it, and so it sorts it in reverse order. Right, in descending order. Now, there's a whole bunch of modifiers that go along with this. So sort is just one of them, and the basic use is that there's the original collection. You apply the query, and you get a subset of the documents that meet that criteria, and then you apply modifiers to transform it for human consumption, to make it more appealing to look at. Again, this is just a subset of all the operators that are available for comparison. Right, so you have equal, greater than or equal, in. Right, so you can have, just like in SQL, right? You can say where a particular field is in, and then you can give it an array of elements that can pattern match against those elements. Less than, or equal, not in. And again, you can go to the documentation. There's a whole bunch of more that are not listed here. Here's some of the logical query operators. There's and, there's not, there's nor, there's or. Right? The ones that you would expect are there. You can also aggregate very much like you can in SQL, right, where you can group things by a particular field, right, and then you can use operators, aggregation operators such as sum or count to aggregate values. There's also limit and skip that allow you to implement things that allow you to do something like pagination, right? I only want to see 10 records at a time. You're going to give me the next 10 records, the next 10 records, the next 10 records, right? Especially useful, for user interfaces that are iterating over large amounts of data. All right, so that's querying data. Let's talk about updating documents, meaning being, well, we already looked at insert, but where you insert new data, what about updating or removing data? So let's take a look at that.